So we talk about measurable space. Okay, so we're done with the sigma algebra. So when do we say a space is measurable? Okay, so the sets, when you have the sample space and in the sigma algebra, that space is called a measurable space. Okay, so it happens that you have a certain sample space defined, and then you found all the possible sigma algebras. So there's a particular sigma algebra you found. So that means all the information about this is found in this sigma algebra. Okay, because all the possible subsets are found in here, which obeys those conditions are found in here, right? So when you put these guys together, right, in a set, you get what you call a measurable space. Okay, a measurable space. Okay, so this is the meaning of a measure. So whenever there is the set, this double, okay, is double, the set that contains the sample space and then the sigma algebra associated with that sample space is called a measurable space. Take note. So example, if this is omega, which is coming from 0 and 1, okay, and you find a sigma algebra which is coming from all the possible subsets, okay, all the possible subsets which obeys the conditions, then the set and then the sigma algebra together is called a measurable space. Okay, now when we say there's a probability measure, okay, probability measure, so now that you have a measurable space, so remember you have to get a sample space. Now when you finish with the sample space, you have to get a sigma algebra, combine sample space and sigma algebra to get a measurable space. Now you have to define probability on it. Okay, so when you define a probability, the probability defined on it is a probability measure. Okay, right. So now that we assign weight to each sample point, okay, we assign weight to each sample point. So what happened is that now there is this sample space 1, 2, 3, all right. So and then we have the sigma algebra associated with that. They will try to assign weight, okay, some weight, and then the weight is what we are saying is a probability measure. We assign weight to the numbers or the outcomes, okay, the sample points. Remember, the sample points are the various items that can happen in the experiment. So you assign weight to that, assign weight to this, assign weight to that, assign weight to that. So it means you have defined a certain probability measure on them. Okay, so this weight is denoted by probability. Okay, so we say that the weight is a probability. So you want to find out the experiment is going on, so what's the probability that you get a 2? So you're looking at P2, alright, P2. So that's the weight. This P2, whichever value that is going to be, will be the weight for 2. Okay, will be the weight for 2. So and call the probability call the probability of the outcome. Okay, so the measure or the weights that we put on, they are the probability of the outcome. Okay, all right. And remember, we assume that the following holds: probabilities are positives, so you can't have a negative probability. So we are saying that the probability or the weight that you are assigning to the outcomes, which are indeed the probabilities, are always greater or equal to 0. Okay, that means it's non-negative. You can't have a negative probability. Okay, and then when you sum, because it's a sample space, it happens that the weight that you give to all the possible outcomes, when you sum all their weights, it should give you a 1. Okay, so the fact that the whole these are the only elements in the sample space that can happen, then the probabilities assigned to each of them, when you sum them up, you should get a 1, and that is the normalization. Okay, so take note of that. All right. So example, you have a fair coin is tossed thrice. We have the following outcomes. So when you toss it thrice, this is the following outcome. Okay. So you want to look at then the weight. You want to assign a weight to this. So probability that you have a head is only 1/8. So it happens that everybody has a weight of 1/8. Okay. All the outcomes in there has a weight of 1/8. So this is the measure. This is the probability measure you put on the sample space. Okay. All right. And then we are extending our case a little bit upward. Okay, so what we are saying is that, okay, if this is a sample space, and then we are assigning weights to them, that is a probability measure we assign to them. And then remember, this is happening once, this is happening once, so probability of this happening is 1/8 for all of them. Okay, for all of them. Now we want to define the probability of an event. Now we don't just want to look at the probability of the outcomes. Okay, we want to look at the probability of an event. Okay, probability of an event happening. Right. So if from this, my interest is to get I want my first to be ahead. So first, I want my first to be ahead. So I want my first to be ahead. Okay, so I want my first element to be ahead. So if I want my first element to be ahead, it means that my event. Okay, that's my event, and it happens that I have a head. All right, head. Then I'll have this one too. So 1, 2, 3, 4. Yeah, I think 4. Okay, so then I'll have head, tail, right? So I'll have head, tail. So this will be my event. That will be my event of interest. Okay, so to find the probability of this my event, I'm calling my event A. To give this event some probability measure, so to give this event some probability measure, we say that the probability is defined as that. Okay, we are defining that probability that I will get head at the first toss, which is this, is equal to, right, the summation of the individual weights assigned to them. So the individual weights assigned to them, I sum them up. So this, the weight of that plus the weight of that plus the weight of that plus the weight of that. Okay, so I have 1/8 plus 1/8 plus 1/8. That would be my probability for the event, not the sample point. Okay, so take note. So let A be the probability that my event of a toss of a coin thrice. The sample space is seen above. All right. So we are defining A. Okay. So A is some definition that at least you have a 2 head. Okay. So I think at least there is 2 heads happening, and so to get a probability, you have to sum up all the individual weights assigned to them, and then that gives you 1/2. Okay, all right. So a fair coin is tossed twice, then the probability function for the sigma algebra consisting of omega is that. Okay, So in that case, if this is what we have, if this is what the sample space we have, then it means you have to assign weights, probability measures to them. So assign probability, there are 4, 1, 2, 3, 4. So each of them have 1 over 4, 1 over 4, 1 over 4. And remember that because the empty set is an impossible event, always the probability is 0. Okay, and then the main set is a sure event or a certain event, so its probability is a 1. Okay, so if I consider 3 of them, 1, 2, 3, then I just have to sum up. I want to know the probability of this happening, then I just have to sum up the individual weights to get my resulting rate. I want to look at HT, then I have to sum up only the 2 and get my result. Okay, so that's a probability measure. Okay.